Okay, so the tool is SLX FPGA from Silexica. So it's a tool that sits on top of Vivado HLS. It helps bridging the gap between C, C++ and FPGA. So the idea is that we do assist the user when there are newcomers to HLS to detect and fix the non-synthesizability in their code. We also detect parallelism in their application, and we also do some automatic pragma insertion and optimization. Here's the tool. So here you can configure the target platform or the FPGA you want to run the software on. You can set some specified. You can specify some used area in case you have some other IP that needs to run on the FPGA. But essentially, the tool is IDE. It's a code-centric tool. What you see here is the original source code, and on this source code, SLX FPGA performs some very advanced static and dynamic analysis to identify a bunch of factors. So among the things that we identify some constructs that are not synthesizable. So that's the structures in your code that cannot be directly ported to FPGA. So when something is identified, the tool not only provides the information, but also provides some hints and guidance about how to fix the thing. So it gives you an example of what is wrong with the code and how to fix it. Now, the SLX FPGA also analyzes the source to detect some parallelism. It identifies dependencies, even loop carried dependencies, to determine which loops are parallelizable, either using data parallelism or pipeline kind of parallelism. And it uses this information in two ways. So the first way is that we use the result of the analysis to give you some hints about what you should care about in your source code. So that's here you see a call graph where you have the hotspot highlighted, so you know where to look at. But we also have some graphs that present to you the memory analysis. So memory analysis basically tells you which variables are in your code, which function access the same variables, but also the frequency at which these variables are accessed, so that you know when there is a problem with memory where to look at and what to fix. Now that's about the information we present to you, but the tool also uses this information automatically to generate pragmas. So here you have a view where you can simply drag and drop functions to map them to FPGA or leave them outside of the FPGA. And the tool will automatically suggest a good configuration for the FPGA. So that means that the tool will present some unrolling, pipelining, array partitioning, inlining, and even interface pragmas that are suited for your use case and your application. So the tool is always code-centric. So every time there is an information, we can actually visualize the link with the source code. So here we identify the loop that is a pipelinable, and the tool thinks it's a good idea to enable pipelining on this loop. So we can immediately see which loop we're talking about, and we can use this information. So when everything is ready, it's also possible to fix the values here. So when this is done, when it is adjusted, if you have needs to adjust it, then we can generate some pragmas immediately in the source code. And there will be a view that will present this information by presenting the original source code and the generated source code, where we see the difference about the pragmas inserted. We have a list of pragmas inserted. We can have a look at all of them and make sure that everything fits our need. And when we're ready, then we can finally synthesize. At the end of the synthesis, when synthesis is done, the result of the SLX FPGA analysis and transformation is actually a bit stream, but the bit stream is integrated into a Vivado HLS project. So we can continue using this project inside Vivado HLS, so the Xilinx tools. It's even possible then to export it to Vivado IP and connect the interfaces and keep going with the usual flow of Xilinx tools. So the tool is built on top of Vivado HLS and SDSoC, but we actually now support the new toolchain, Xilinx Vitis.